Systems of equations problems are some of the tougher problems you'll encounter on the math portion of the SAT. The trick is to practice enough of them so that you can quickly identify one when you see it. There are two methods for solving systems of equations problems: substitution and elimination. Substitution depends on getting a variable by itself so that you can plug that into the other equation. So in this problem we have here, I have x by itself being added to 3y. If I subtract 3y from both sides, x is equal to 8 minus 3y. Now that I know what x is, I can plug that in as x to the other problem. So 4 times 8 minus 3y plus 2y equals 22. I can distribute. Then I can combine my like terms, and I can subtract 32 from both sides, divide by negative 10, and y comes out to 1. Now that I know that y is 1, I can plug that back into either of the equations. X plus 3 times 1 equals 8. I can subtract 3 from both sides, and x equals 5. To solve the same problem by elimination, I can just create a situation where one of the variables will cancel out. Since I have 4x in one of my sentences, it will be awful nice to have negative 4x in the other. I can create that situation on purpose by multiplying the whole equation by negative 4. That gives me negative 4x minus 12y equals negative 32. Then I can rewrite the first sentence below it, 4x plus 2y equals 22, and add straight down. The x's cancel. 2y minus 12y is negative 10y, and 22 minus 32 is negative 10. I can divide both sides by negative 10, and y comes out to 1. Now, just like we did before, I can plug 1 in as y, so x plus 3 times 1 equals 8. I can subtract both sides by 3, and x equals 5. In this problem, the square of x is equal to 4 times the square of y. If x is 1 more than twice y, what's the value of x? Well, the first thing I can do here is take both of the sentences they gave us and turn them into algebraic sentences. The square of x is equal to 4 times the square of y. The other one is that x is 1 more than twice y. So now, if we need to solve for x, it would help to notice that x is already by itself. X is equal to 1 plus 2y. So I can go to the other equation, and wherever I see an x, I can plug in 1 plus 2y. Therefore, 1 plus 2y squared equals 4y squared. And if I'm squaring a binomial, what I want to do is write the binomial twice, multiplying it by itself, and then FOIL it out. First times first equals 1. Outer times outer equals 2y. Inner times inner is 2y. And last times last is 4y squared. And all of that is still equal to 4y squared. As is the case on many SAT problems, something will naturally cancel out and make the whole problem easier to solve. In this case, if we subtract 4y squared from both sides, we're left with a much easier problem to solve. 1 plus 4y equals 0. Subtract 1 from both sides, divide both sides by 4, and y equals negative 1/4. Be careful here, because if you were to pick negative 1/4 as your answer, which is very common, you'd get the problem wrong, because they're not asking us for y, they're asking us for x. X is equal to 1 plus 2y, so I can plug in the fact that y is equal to negative 1/4. X is equal to 1 minus 2/4. Simplify the 2/4 to 1/2, and 1 minus 1/2 equals 1/2. So x is equal to 1/2, and that's our answer. Next problem. A certain fraction is equal to 1/3. If 1 is subtracted from the numerator and the denominator is divided by 2, the resulting fraction is equivalent to 1/2. What is the denominator of the original fraction? If we're talking about a certain fraction and I need the numerator to be different from the denominator, I can call that x over y, and that fraction is equal to 1/3. To get rid of the fractions, we can cross multiply. 3x equals 1 times y, which is y. For the next sentence, if we take that same fraction x over y, we subtract 1 from the numerator, and we divide the denominator by 2, that new fraction is equal to 1/2. Here, it's important to be very comfortable with the idea of a fraction within a fraction. Y over 2 can be our denominator, and that's fine. There's a couple of ways to simplify that situation. In this situation, we can cross multiply. 2 times x minus 1 equals 1 times y over 2. To get rid of the fraction on the right hand side, we can multiply both sides of the equation by 2. And 4 times x minus 1 equals y. Distribute, and we get 4x minus 4 equals y. Earlier we found that y was equal to 3x. So here, instead of y, I can plug in 3x. 4x minus 4 equals 3x. Take away 4x from both sides, divide both sides by -1, and x equals 4. Once again, be careful, because 4 could likely be listed as one of the answers, and that's not what we're looking for. We're looking for the denominator, which is y. So we can plug in to y equals 3x, plug in the fact that x is 4, and y equals 12. Next problem. The total cost of a car rental is the sum of a basic fixed rental charge for the car and an additional charge for every 25 miles traveled. If the total cost to rent a car and drive it 50 miles is $200, and the total cost to rent a car and drive it 200 miles is $245, what is the total cost in dollars to rent a car and travel 450 miles? The hardest part of this problem is setting up a general equation that talks about the cost of renting the car and driving it in any situation. The cost, C, is equal to some base price, B, plus an additional cost, A, that's only charged for every 25 miles traveled. The m over 25 can be explained as, if we drove 50 miles, it would be 50 over 25, and we'd have the charge twice. If we drove 75 miles, it would be 75 over 25, and we'd get the additional charge 3 times. So let's plug in the information they gave us. It costs $200 to rent the car, and we don't know the base fee, and we don't know the additional fee, but we're driving it 50 miles, so we plug in 50 over the 25. I can simplify that and say 200 equals B plus 2A, because 50 over 25 is 2. Also, it costs $245 to rent the car, we still don't know the base fee, and drive it 200 miles, so we plug in a 200 for M. Now, because 200 over 25 is 8, we can simplify that whole equation. 245 equals B plus 8A. Now, I can take the top equation and multiply the whole thing by -1, because that'll get our b's to cancel out. When I multiply the whole equation by -1, I get -200 equals -b minus 2a. Now I can add straight down with both of these equations, and we get 45 equals, the b's cancel, and we have 6a on the other side. Divide both sides by 6, and a equals 7.5. Now that a equals 7.5, we can plug that back in to find b. So 200 equals b plus 2 times 7.5. 2 times 7.5 is 15, so we can rewrite it. We can subtract 15 from both sides, and b equals 185. Knowing a and b, we can rewrite our master equation to accommodate the cost in any situation of renting the car and driving it any number of miles. C equals 185 because B is 185 plus 7.5 because A is 7.5 times M over 25. M is the number of miles that we're driving. Then finally they're asking us what happens when we rent the car and drive it 450 miles. So for M we can plug in 450 and we get C equals 185 plus 7.5 times 450 over 25. 450 over 25 is really 18. And so we get 185 plus 7.5 times 18, which is 135. And 185 plus 135 equals 320. There's another type of systems of equations problem that I like to call a comparative groupings problem. Generally, it talks about two groups, men and women, cats and dogs, Democrats and Republicans, what have you. And often, you can formulate one sentence just by describing the total number of objects. Let's take a look at a problem. A restaurant has 19 tables that can seat a total of 84 people. Some of the tables seat 4 people and others seat 5 people. How many tables seat 5 people? If we call X the number of tables that seat 4 people and Y the number of tables that seat 5 people, we can come right out and say that X plus Y equals 19. The next sentence might add up to 84 because they're telling us that there are 84 people. If we wanted to add up the total number of people, we can take the number of tables that seat 4, which is X, times 4, which is the number of people at those tables, plus the number of tables that seat 5, which is Y, times the number of people at those tables, which is 5. So 4x plus 5y equals 84. Now I can take the first equation and multiply it by -4. The reason I'm doing this is because since I have 4x, I want to have -4x so my x's will cancel. When I distribute the -4, I get -4x minus 4y equals -76. Add both equations straight down, the x's cancel, and y equals 8. Now we don't even need to plug that in to solve for x here because they're asking us how many tables seat 5 people, which we said was y. And so y equals 8 and our answer is 8. Now you can see how convenient it is to write a little note to yourself as we did, describing what your variables mean. If I didn't stop and say that x is the number of tables with 4 people and y is the number of tables with 5 people, I might have picked a different answer. I might have picked whatever x is and selected that. And this happens really frequently on systems of equations problems, so you want to be very careful. Next problem. On a math test, all the students in a class received either a 75 or a 95. If 25 students took the test and the average grade was an 83, how many students earned a 75? If x is the number of students that scored a 75 and y is the number of students that scored a 95, we can start right out by saying x plus y equals 25, since there are 25 students in total. Now, the other thing they're telling us about is the average, and if I'm averaging test scores, I'm adding up all the points that all the students scored, and I'm dividing by the number of tests. So, I'll be dividing by 25 since there were 25 tests. If I want the sum of all the points, this is similar to adding up the number of people at tables in the previous problem. I need the number of people that scored a 75, which is x, times 75, plus the number of people that scored a 95, which is y, times 95. And when we go ahead and take that average, it comes out to 83 because the problem told us that the average is 83. To simplify this sentence, we can multiply both sides by 25. So 75x plus 95y equals 2075. Now, if I want the other equation to have negative 75x in it, I can multiply that whole equation by negative 75. Distributing that, we get negative 75x minus 75y equals 1875. Negative 1875. Adding straight down, the x's cancel, and we have 20y equals 200. Divide both sides by 20, and y equals 10. Once again, be careful here, because 10 is likely to be one of the, but it's not right, because we're not looking for the number of people that had a 95, which would be 10. We're looking for the people that had 75s. So we have to plug into one of the sentences, x plus y equals 25, and we'll plug 10 in for y. So x plus 10 equals 25. Subtract 10 from both sides, and x equals 15. Next problem. Frances trained for her swim meet by swimming to a nearby island and then swimming back. On the way there, she swam at a rate of 10 miles per hour, but on the way back, she grew tired and swam at a rate of 7 miles per hour. If the total trip took 2 hours, how far away was the island? This is a distance equals rate times time problem, and it has two legs, the leg on the way there and the leg on the way back. This type of problem can be very confusing if you don't structure your work in a way that's easy for you to understand and to keep organized. On the way there, the distance on the way there equals the rate on the way there times the time on the way there. The rate on the way there is 10, and we don't know the time on the way there yet. On the way back, the distance on the way back equals the rate on the way back times the time on the way back. We know that the rate on the way back is 7, so we can put that in. Now, because it's a round trip, the distance on the way there and the distance on the way back are equal to one another. So I can say 10 tt equals 7 tb. Divide both sides by 10, and tt equals 7/10 tb. Now, because the entire trip takes 2 hours, I can also write another equation. The time on the way there plus the time on the way back equals 2. The time on the way there equals 7/10 tb, so I can plug that in. 7/10 tb plus 10/10 tb, because 1 is equal to 10 over 10, equals 2. And 2 equals 17/10 tb. I can multiply by the reciprocal on both sides, and the time on the way back equals 1.18. So now we know the time on the way back, and we're pretty much at our answer. All we need to do is use one last distance equals rate times time formula just for the way back. The speed on the way back was 7, and the time on the way back we just found out was 1.18. 7 times 1.18 is 8.2, and so therefore the island was 8.2 miles away. Next problem. Roxanne drove to the circus at an average speed of 30 miles per hour. She returned home along the same route and averaged 25 miles per hour. If her total travel time was 2 hours and 12 minutes, how many miles did she drive on her return from the circus? This is another problem with the D equals RT scenario for both legs of the trip, for the way there and for the way back. On the way there, the distance on the way there equals the rate on the way there times the time on the way there. The rate on the way there is 30, so D equals 30 tt. On the way back, the distance on the way back equals the rate on the way back times the time on the way back. The rate on the way back is 25 tb. Now, the two distances are the same because she's driving to the same place and she's returning to the same place. So, I can say the distances are equal. 30 tt equals 25 tb. Divide both sides by 30, and the time on the way there is equal to 5/6 of the time on the way back. The other thing they told us is that the entire trip was 2 hours and 12 minutes. So, the time on the way there plus the time on the way back equals 2 hours and 12 minutes. The 12 minutes, I'm going to go ahead and use a conversion ratio to convert it to hours. The reason I want everything in hours is because the rates are in hours. If I leave it in minutes, I'd have to convert everything else into minutes as well. So I'm going to multiply the 12 minutes by a fraction of 1 hour over 60 minutes. That gets my minutes to cancel, and 12 divided by 60 is 0.2. 2 plus 0.2 is 2.2. So the time on the way there plus the time on the way back equals 2.2. Now, the time on the way there is equal to 5/6 the time on the way back. So I'm going to substitute that in. 5/6 times the time on the way back plus 1 times the time on the way back equals 2.2. 1 is equal to 6 over 6, so 5/6 TB plus 6/6 TB equals 2.2. That's 11/6 TB equals 2.2, and I can multiply by the reciprocal. The time on the way back is 1.2. Now I just need one more D equals RT formula, and I can say the distance on the way back equals the rate on the way back times the time on the way back. That's equal to 25 times 1.2, which is 30. So on her return from the circus, she went 30 miles.